Hi, welcome to Real-Time Signals Technologies. Today we are going to discuss about the version control tool Git. First, we have to know about challenges in code management. 1. Maintain copies of files based on date and time they were changed. While working on a feature to get customer details, one would name the file getCustomer.java using different naming conventions to track its versions. Example, code completed at end of the 15th of February would be named getCustomer_15February.java followed by getCustomer_16February.java and so on. And if you want to save the code at multiple checkpoints in a day, then the naming conventions for the file will become even more complicated. 2. Track changes made to files by different team members. Suppose you're working in a team of 6 members writing tests for a particular feature. It's imperative to ensure that there's no duplicate or ambiguous code. Also, team members should reuse code already developed by other team members. And also ensure that everyone uses the latest version of code developed by others. This would be an excruciating task for a team consisting of multiple people, especially if they're working in different locations. 3. Trace the file's history to find the version of code which introduced the bug. Code undergoes regular changes either during development or maintenance phases. It's quite possible to inadvertently change something that causes the code to misbehave and not work as expected. In such situations, it'd be helpful to view the timeline of changes in code to pinpoint the exact cause of bug. 4. Maintain backup of your files. In an unfortunate situation of hard disk being corrupted or being subject to some malicious virus, working copy of your code is highly vulnerable. As a result, it's highly likely to lose all of your work in absence of proper backup of your code. 5. Comment add blocks of code to disable a functionality without deleting it. When the code is still in development, you might write a small sample piece of code to see how a particular method behaves. Irrespective of whether this experimental block of code tests your feature or not, you'd like to retain it for reference. It's not feasible to maintain multiple versions of files by commenting and uncommenting different blocks of code. Under light of all these issues, there has to be a better way of maintaining the versions. Hail version control systems. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. For the examples in this book, you'll use software source code as the files being version controlled, though in reality you can do this with nearly any type of file on a computer. If you are a graphic or web designer and want to keep every version of an image or layout, which you would most certainly want to, a version control system, VCS, is a very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might be causing a problem, who introduced an issue, and when, and more. Using a VCS also generally means that if you screw things up or lose files, you can easily recover. In addition, you get all this for very little overhead. Local version control system. Many people's version control method of choice is to copy files into another directory. This approach is very common because it is so simple, but it is also incredibly error-prone. It is easy to forget which directory you're in and accidentally write to the wrong file or copy over files you don't mean to. To deal with this issue, programmers long ago developed local VCSs that had a simple database that kept all the changes to files under revision control. Local version control system maintains track of files within the local system. This approach is very common and simple. This type is also error-prone, which means the chances of accidentally writing to the wrong file is higher. Centralized version control systems. The next major issue that people encounter is that they need to collaborate with developers on other systems. To deal with this problem, centralized version control systems (CVCSs) were developed. These systems, such as CVS, Subversion, and Perforce, have a single server that contains all the version files, and a number of clients that check out files from that central place. For many years, this has been the standard for version control. This setup offers many advantages, especially over local VCSs. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's far easier to administer a CVCS than it is to deal with local databases on every client. However, this setup also has some serious downsides. The most obvious is the single point of failure that the centralized server represents. If that server goes down for an hour, then during that hour nobody can collaborate at all or save version changes to anything they're working on. If the hard disk the central database is on becomes corrupted, and proper backups haven't been kept, you lose absolutely everything. The entire history of the project except whatever single snapshots people happen to have on their local machines. Local VCS systems suffer from this same problem. Whenever you have the entire history of the project in a single place, you risk losing everything. This is where distributed version control systems (DVCS) step in. In a DVCS such as Git, Mercurial, Bazaar or Darks, clients don't just check out the latest snapshot of the files, rather, they fully mirror the repository, including its full history. Thus, if any server dies, and these systems were collaborating via that server, any of the client repositories can be copied back up to the server to restore it. Every clone is really a full backup of all the data. Furthermore, many of these systems deal pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people in different ways simultaneously within the same project. This allows you to set up several types of workflows that aren't possible in centralized systems, such as hierarchical models. Git is a version control system (VCS), and that to be distributed VCS, which was developed by Linus Torvalds, the same engineer who developed Linux operating system. The situation which made him code Git is the actual definition of VCS. Linus Torvalds thought of a version control system for his operating system Linux because there did not match any available system to match his needs. This was much needed since Linux was open source and many developers wanted to contribute to Linux. A VCS would bring about a greater pace in the patch release and the development of this OS. All this made him develop Git, which is a version control system. Since the development and release of Git, it has gained a huge popularity among the developers, and being open source have incorporated many features. Today, a staggering number of projects use Git for version control, both commercial and personal. Let's see why Git has become so popular by discussing its main features. 1. Performance. Git provides the best performance when it comes to version control systems. Committing, branching, merging all are optimized for a better performance than other systems. 2. Security. Git handles your security with cryptographic method SHA-1. This algorithm manages your versions, files and directory securely so that your work remains only yours. 3. Branching model. Git has the most different branching model than the other VCS. Git branching model lets you have multiple local branches which are independent of each other. Having this also enables you to have frictionless context switching, switch back and forth to new commit code and back, role-based code, a branch that always goes to production, another to testing, etc., and disposable experimentation. Try something out, if does not work, delete it without any loss of code. 4. Staging area. Git has an intermediate stage called as index or staging area, where commits can be formatted and modified before completing the commit. Phi. Distributed. Git is distributed in nature. Distributed means that the repository or the complete codebase is mirrored onto the developer's system so that he can work on it only. 6. Open source. This is a very important feature of any software present today. Being open source invites the developers from all over the world to contribute to the software and make it more and more powerful through features and additional plugins. This has led the Linux kernel be a software of about 15 million lines of code. In the IT industry, there are two terms that are used frequently, Git and GitHub. Both refer to two different entities. Let us see what is the difference between Git and GitHub. Git. It is a distributed version control system for tracking versions of files. GitHub. It is web portal and cloud hosting service for your Git repositories. That's it. Git is the magic sauce that allows you to track and host versions of files on GitHub. In other words, you use commands of Git to track versions of your files. And GitHub is just a remote platform where these files are hosted. However, if this explanation didn't satisfy your queries, then read on the following points elaborating more about these two terms and the usage. GitHub is the most popular Git hosting service today. The main secret of its success is the free plan with free unlimited public repositories. Although you need to pay for private repository, but almost every open source project chooses GitHub for the project. There are many other good features as web pages, issue tracking or source code snippet sharing, etc. These make it stand apart from the others. Files in a Git project have various stages like creation, modification, refactoring, and deletion, and so on. Irrespective of whether this project is tracked by Git or not, these phases are still prevalent. However, when a project is under Git version control system, they are present in three major Git states in addition to these basic ones. Here are the three Git states. 1. Working directory. Consider a project residing in your local system. This project may or may not be tracked by Git. In either case, this project directory is called your working directory. 2. Staging area. In other words, staging area is the playground where you group, add and organize the files to be committed to Git for tracking their versions. 3. Git directory. Git directory is the database where metadata about project files history will be tracked. These stages are the essence of Git. You get great flexibility in tracking the files due to these stages that files can reside in under Git. Let's understand each of these states one by one. After learning about these stages, one might naturally ask, why is staging area required? Why can't we directly commit the code instead of first adding it to the staging area? Let's understand the reason behind this with help of following points. 1. Fast Git operations. Staging files regularly yields in very fast Git operations. A commit is essentially a resource-expensive interaction with the Git database. For those with background of SVN, a client-server model-based VCS, know that every commit requires considerable time. This is because it has to first traverse the SVN commit tree to check if there have been any commits made by other users before the last commit made by us. Consequently, commit operations tend to be slow. However, in case of Git, staging the files doesn't need interaction with the Git database. It's only when the files have to be committed that Git check for presence of commits made by other users. Thus, staging helps in recording the changes even before committing them to Git database. 2. Visualizing the commit before actual commit. As discussed earlier, staging area is the state in which the files reside before they're committed. That is, staging area actually lets you visualize the group of changes that will be recorded by Git. Essentially, this gives you fine-grained control over what gets committed to Git and what does not. 3. splitting work into separate related commits. Apart from the first commit, when all the project files are committed at once, you should take snapshot of the project at regular intervals. That is, suppose you're working on a new feature whose timeline of development runs into several days. So, while you're working on the feature, you are required to refactor a small part of the code. In this case, you can quickly make the required changes, stage the required file, and resume work on the feature. All of the changes, i.e., feature changes and refactor code, can be committed at once from the staging area. Get ready to use Git. Set the name and email. Forget to use when you commit. Git config global user.name bugs bunny. Git config global user.emailbugs@gmail.com. Git config global push.default simple. You can call git config list to verify these are set. These will be set globally for all Git projects you work with. You can also set variables on a project-only basis by not using the global flag. You can also set the editor that is used for writing commit messages. Git config global core.editor emacs. The purpose of Git is to manage a project or a set of files as they change over time. Git stores this information in a data structure called a repository. A Git repository contains, among other things, the following: a set of commit objects, a set of references to commit objects called heads. The Git repository is stored in the same directory as the project itself in a subdirectory called Git. Note differences from central repository systems like CVS or Subversion. There is only one Git directory in the root directory of the project. The repository is stored in files alongside the project. There is no central server repository. Here are the main Git commands generally used: git config, git init, git clone, git add, git commit, git diff, git reset, git status, git room, git log, git show, git tag, git branch, git checkout, git merge, git remote, git push, git pull, git stash. To push your changes from your local repo to the remote repo: 1. Create a new repository on GitHub. 2. Open terminal git bash. 3. Change the current working directory to your local project. 4. Initialize the local directory as a Git repository. 5. Add the files in your new local repository. 6. Commit the files that you've staged in your local repository. To push the most recent updates from the remote repo: 1. After pushing your local changes to your remote repository, point your browser to your repository on GitHub. 2. Click the Pull Requests tab. 3. Click New Pull Request. 4. In the Base drop-down, select Master. 5. In the Compare drop-down, select the branch you recently pushed to the repository. In computing, a log file is a file that records either events that occur in an operating system or other software runs, or messages between different users of a communication software. Logging is the act of keeping a log. In the simplest case, messages are written to a single log file. Following are the git log commands: 1. Git log. 2. Git log 1 line grep workspace. 3. Git log branch name. 4. Git log -1. Say you are working on a paper. You've gotten a first draft out, submitted for review. You then get a new batch of data, and you're in the process of integrating it into the paper. Halfway in, however, the review committee calls you up and tells you that you need to change some of your section headings to conform to format specifications. What do? Obviously you don't want to send them your half-baked revisions with corrected headings. What you want to do is jump back to the version you sent out, change the headings on that version, and send off that copy, all the while keeping your recent work safely stored somewhere else. This is the idea behind branching, and Git makes it easy to do. Git Advantages. 1. Resilience. No one repository has more data than any other. 2. Speed. Very fast operations compared to other VCS. 3. Space. Compression can be done across repository, not just per file. Minimizes local size as well as push-pull data transfers. 4. Simplicity. Object model is very simple. 5. Large user base with robust tools. Git Disadvantages. 1. Definite learning curve, especially for those used to centralized systems. Can sometimes seem overwhelming to learn. 2. Documentation mostly through man pages. 3. Windows support can be an issue. Can use through Sigwin. Also have the Git project. Git Architecture. 1. Index. Stores information about current working directory and changes made to it. 2. Object database. 3. Blobs files. Stored in Git objects. Indexed by unique hash. All files are stored as blobs. 4. Commits. One object for every commit. Contains hash of parent, name of author, time of commit, and hash of the current tree. For further information and training, contact. Call us 97409925552. Email info@realtimesig.com. For online and e-learning, visit www.edjio.com. Marathon Office. Real-Time Signals Technologies Private Limited. 102 Krishna Grand over Marathali Bridge. Bangalore, Karnataka, India 560037. BTM Office. Real-Time Signals Technologies Private Limited. 4, second floor, first phase, second stage, BTM layout. Opposite to Udupi Garden. Bangalore 76, Bengaluru, Karnataka 56076.